Hello. Hi there. Thanks to be here. I'm Rob from Italy, and I'm in the city of Witailer. I've been a consultant for companies for years. I wrote some book on Azure, and today I'm here to talk about data, especially the integration of JSON documents inside a relational database like SQL Server. That in Azure is called also SQL Azure or Azure SQL Database. That is the managed version of SQL Server that you probably may know because of your usage on premise. Okay, so to go straight to the point, this is not a fight, okay? I don't want to say that relational is better than NoSQL. I use both since I think in the last 10 years, I think I used NoSQL as well as relational. I strongly believe that you need to mix those two ecosystems, those two words, to take the better from them. So if you are going to search for instance, you would probably go through a product that is similar to Elasticsearch or a NoSQL that is optimized for that, okay? But if you are going to create some integration with a visualization tool like Power BI, Tableau software, something like that, of course, the relational world is still the main way to go through that problem. Okay, it's not the only one, because that kind of solution that the modern business intelligence teams are growing up with, also the concept of data lake, data lake house, integration with the unstructured document, and the direction is that, but it's not a unique direction. Okay, so in this session I would like to share my opinion about that it's not a fight between two words, but an integration, okay, between the two. So let's take this approach. An assumption. If you want to make some question about this session, you can use the Q&A feature on the Pine tool. I have another monitor on that, so I can see it live. So feel free to write them, and no problem. I will answer your questions. So let's try to analyze a common scenario, okay? The scenario when you need to integrate data sources from outside to integrate them and provide the resulting data to your internal or external customers, okay? So take in mind you are dealing with JSON, for instance. So JSON that are coming from an API, from a reporting system, from a third party, from a partner. Okay, so it doesn't matter from where it comes from, but it arrives. Okay, so you need to prepare it, to clean it, to remove the stuff, to add some surrogated stuff, okay? And then you will probably engineer the place that will contain that piece of data, okay? So, for instance, the database, the tables, the relationship between the tables, if you are dealing with a relational database management system, okay? After that, you need to ingest this one shot or even continuously. So the ingestion is another great big topic on the block. So it will probably deserve an entire session, an entire course probably. But assume that we are ingesting that data in some way. So with a pipeline tool in Azure, there is a tool called Azure Data Factory that is also integrated in Synapse Analytics. But you can use even your custom code. You can use SQL Server integration services. You can use other third-party tools that are very popular. After that, we have the data inside the database, but at that stage, it's not really given that it's ready to be consumed, okay? So probably should be transformed again from the 2, 3, 4, 10 tables where the data resides. You should probably create some views to aggregate the data and produce the aggregate that the consumer wants, okay? And finally, there's the data consumption. Okay, so with this approach in mind, let's go straight to the point. Well, okay. Issue: data may change. Okay, so in the incoming JSON, you can have unexpected entities. So something more, okay? So you probably need at some point to filter that stuff. So like if the current entity is a type of A, okay, if type of B, throw it away, something like that. In case of new fields of a particular entity type, I think it's not really a problem, okay? You can ignore them in production. It's a common path is to ignore that, okay? You can have missing fields. Okay, if you have missing fields, you should be aware of that. And if you are transforming the data to something that is relational, so field in JSON should be a field on the table, you should keep in mind that this field on the table can be nullable if you think in advance that this field should be missing. In case you think it's a mandatory field, but the same, you find it null or missing, this could lead to a problem, okay? So when you transform, when you integrate those two words, you should keep in mind this kind of issues and take the proper actions, okay? So the example in this session uses two different JSONs from the same Kaggle dataset that is published online. It's open source, okay? There are two JSON. One is a movie JSON, okay, like, I don't remember the numbers, but like 10,000 of movies with title, the plot, and the rating, something like that, and the reviews of that movies. Especially that Kaggle dataset is about spoiler alert and so on, but it doesn't matter, okay? Reviews, there are many reviews for a single movies, okay? The reviews JSON is about 1 gigabyte, okay? So I want to integrate those two JSONs into the SQL word to produce a consolidated view, okay? Good. So let's get the data just to know where they are, okay? They are... I took the data here. So this is, as I said, the movie details. So an item is something like that. And this is the item of the reviews. Okay. As I said, this is quite a gigabyte of information. So I want to give you an advice when you deal with those huge JSON files. There's a tool, really nice tool that is called JSON Viewer that you can use. Hold on a second. Okay, can use it to read in seconds huge JSON files. Okay, this is the movie one, so it's not so huge. But if I drop the reviews one, that is about 1 gigabyte in, I think, 5 seconds, something more. Okay, 10. Okay, 5 seconds. Yeah, it loads the content, and I can filter it here. I can drill down into the data here. So it's a nice tool to see your big JSON files before you're working on them, okay? Good. So let's come back to the presentation. And now we have the JSONs, and we want to engineer the tables, so the relational tables that will hold those data, okay? Let's do that. So this is, I want to give you a suggestion about that. I don't know if in my audience today there are people from the Microsoft ecosystem, the .NET ecosystem, and but in the Microsoft world, it's very common to use Visual Studio or Visual Studio Code. And in Visual Studio, there's a project type that is called SQL Server project, database project, or something like that. It's a project type that holds the database object of a desired database to integrate those development process into the same development process you are accustomed with when you write code, you write C# code, okay? In this case, I want to create a table, and I create that table inside this, okay, graphical designer, but also inside this environment to have all the objects of the table as files, but better to have something more. For instance, let's take the reviews table that has a foreign key to the movie one. If I change because I made a mistake, a name, the project will not build anymore. So This kind of approach helps you to write consistent database object in a build-like fashion. So when I build that, there's no compilation, of course, because you have nothing to compile, okay? But the database project helps you to identify errors in relationships, in data types, in rules, in indexes, and so on. So it's my advice to use a tool like this, or even other tools, because if you are accustomed with this word, you probably know Redgate, you probably know products that are really enterprise grade for that. Okay, in my personal point of view, this is necessary, because when you go that way, you cannot go back. You will version that in Git, and you can also revert it. You can integrate that part of the process into the your pipelining, your application lifecycle management. So it's really something that you can't avoid. Okay. So, well, in this case, I want to point this table, okay, the reviews table, okay. Let's take the movies table as granted, and let's go on to the reviews table. This is the review ID that, unfortunately, is not present here, okay. It's not in the original data source, because probably they decided it's not doesn't matter, and it doesn't matter effectively. Okay, so in the relational database world, since I want to have a primary key, because under the hood I also want a clustered index, that I introduced this primary key that is surrogated. It's false. Okay, it's something that is not really tied to the semantic of the data. Okay, just something that I invented to be consistent and compliant to the relational world. Okay, so this is my first issue. I don't like it so much. Okay. The second is this one that is really good. So the foreign key. So the foreign key is the basic main concept that you put relation from a table to another table. Okay, and you enforce that in the database level. So in this case, we are telling that no rows can be inserted in the reviews table if there's no the respective movie ID in the movies table. Okay. Also, this constraint could lead to error, because I realized, looking into the dataset, looking into the JSONs, that some movies, some reviews came down without the respective movie in the other JSON file. Okay, and probably you will say, okay, it's not consistent. Okay, because if you have reviews without the movie, it's a nonsense. Okay, but in big data scenario, you should probably have that situation, and you should probably take the good part of the data just from the part that you have. So keep in mind, and if you deal with big data, you can probably have some dirty data. You can probably have some reviews without the respective movie, and you can use that part. Okay, you can just use the part that you have. Okay, so in this case, we are forced to throw away the movies, the reviews that have no movies attached. Okay, good. So we engineer, this is the intermediate step. Then I click over there, or even in the publish part, and I produce a database inside SQL database. Okay, this is the part it's missing in the demo, but it's a matter of seconds and just a couple of minutes. Okay, the process compares the status between the local project and the database and apply the changes that are missing. So if you are just changing something like this, the project type will generate a script that just alters the review date field in the reviews table without making any other change. Okay, good. So let's go ahead. Now we need to ingest the data and transform the JSON inside the database to produce it in a form that is consumable by our internal or external customers. Okay, so let's go through this. I just take a look if there are any questions. Okay, no. And then just a few words about the ingestion. As I mentioned in the introduction, you can ingest the data with your custom tools. My preferred approach in the latest couple of years, passed from custom C# tools with some really good optimizations to something that is more scalable, like Azure Data Factory. That's an integration to data preparation tool. So think about you design a flow, you design a pipeline, take the data here, transform, group by, filter, do that, etc., and then write back to the database. Something like that. Okay, in a visual way. Good. For this demo, however, I used a C# program to let this for you on GitHub. So if you go on GitHub, you will find those examples of importers. So for instance, this reads from the JSON, and for each movie that it finds inside the JSON, it will write an entity into the context and then save the changes through entity framework. That is a really good ORM in the Microsoft ecosystem. Good. So let's take this for granted, and let's take a look on the results in the database. This is the relational table. So when I say relational, they are all relational. Okay, but in this demo, I would split the real plain old relational way from the JSON and the hybrid JSON approach. Okay, this is the plain old structure. So the single item has been transformed into something that has a movie ID that is varchar. This is varchar max, time, decimal, and so on. Okay, and this is the result. The generate itself, it's a JSON inside a varchar field. Okay, because it's like tagging. So there are some fields, some items like 2, 3, 10, okay, in an array. So this is the preferred way to hold them, probably. The same for the reviews, and that's okay. And I wanted to create this view that mix the two things, so movies and relational, to have the aggregate that I want to produce for our consumers. Okay, so in our aggregates, we have the movie ID, the plot, duration, genre, rating, release date, synopsis, the review ID, no, because it's just surrogated. The review date, movie ID is already here, user ID, if the review is a spoiler, the review text, the rating that I rename to review rating, and review summary. Okay, let's save this as view 1. Okay, and let's take a look. Okay, this is the the right way to express it is the word denormalization. Okay, when you deal with database, you will probably normalize the data. So avoid duplicates and structure the tables to have just unique values to then join them and produce the aggregates that you want. This kind of aggregates is the denormalization of the two tables, because in each row it appears the same information about the movie and then the specific information about the review. Okay. Well, now let's start with the JSON part. Okay, so we are at the corner. We can keep the tables, the relational tables, or try to avoid them for a more NoSQL approach into the relational database. You should keep the tables when the use case is really simple to understand. Think about a row of a movie, of a row of a review. If you need to edit a single field, for instance, the rating, for instance, the text, of a movie or a review, you should probably keep the tables. Why? Because if you have that data inside the JSON and you just need to update a single field, you should read the JSON, update that, and write back to the database. This is the only way to do that now in SQL, in Azure SQL Database, for instance, or in SQL Server. In other NoSQL products, you will probably go to the single entity and update just the field, and it's okay. In SQL, no. So if you need to do that, you should keep the tables. But if you have an immutable objects, okay, so objects that are not really editable because it doesn't make sense if you edit them. For instance, the weather. The weather is something that when you realize the weather of yesterday, it doesn't change anymore. Okay, so I would say that it's immutable. So if you are dealing with a review of a movie and the movie itself that has a plot, okay, and okay, the rating can change, but think about the title, the plot, and the review itself. Some one of you may say that also reviews may change. Okay, but keep in mind that in that case you will think that this could be immutable data. Okay, in this case, it's interesting to hold the data inside the JSON because we do not need to go into the JSON itself to change a field, change a value, but we just read that and transfer that in the way we want. Okay, so now we are going to see the two approaches of JSON, mainly one, but I would mention also the hybrid approach. Hybrid is not something from the industry, just something from me, okay? Because when we realized that, where I work now, when we realized that we can use JSON, we wanted to go step by step. So we try to use a small amount of data in JSON in place with relational fields. Okay. After that, we realized that the process was good, was strong, was consistent, and we embraced a full JSON approach. What is the difference? In a hybrid approach, in my opinion, some fields are plain old SQL fields. Okay, with those ones. And some other fields are containing the JSON. So in this case, if I take a row from JSON, this hybrid, I would say that those are plain fields, and this is the JSON with the array of the reviews of that movie. Okay, but I strongly prefer the full approach where I put on JSON everything I can. Okay, so in this case, I put on the JSON, on the varchar max, so the fields that contains the JSON, everything I have, so the two entities from the two files. The only field that I wanted to take out from that is the ID, just to put a key on that. Okay, but it's you will see that it's not really necessary in advanced scenarios. Okay. So in this case, we have the movie ID, the movie object, and all the reviews in a JSON array format. Okay. So now let's try to produce this kind of aggregate to our customers, okay, to our counterpart. So let's take and just to have a sample. Okay, let's take this one. Let's say where movie ID. Okay, so I can avoid to put the top here, and we are working just on this row to experiment the JSON function that are native to SQL database. Good. So the first function is the JSON value. JSON value says, okay, give me a field that contains a JSON, and give me the path you want to extract. So point plot summary as a plot summary, comma. Okay, here we are. So it took out this from the JSON to put it there. Okay, so with this on my other screen, just to help to do this smoothly, I will produce all the fields that are needed. Okay, so I take from the database just the movie ID, then plot summary, and then I have duration, I have genre, I have rating, yes, rating, okay. I have release date, okay. And I have plot synopsis. Okay, this is okay. Some monkey business. Genre is not working. Plot synopsis is null. Okay, plot synopsis is a string, but it's optional in my experience on this dataset, so it's good. Instead, genre is always down, but which is the problem? The problem is that genre is an array itself, a JSON array itself. So when we have structures that are not really understandable as varchar by the platform, or you cast them, or you just say, hey, in this case, just keep the JSON as it is from that field. And it's okay. After that, pardon, I want those to be casted to the right type. So release date should be a date. Okay. You will not notice any difference when under the hood this is now a date, so it can be added and subtracted to other dates and use in the application to perform a computation on that. But in case you have a release date that is not really well formatted, that it's not understandable easier from the SQL engine, it will throw an error. So I would just say to try cast all your data. Okay. We can also make some interesting and fancy transformation about the duration field. Okay, we can, for instance, say replace this stuff, replace H with something like that. And we can do the same with min. We can put other column with 0, 0, and we can transform this is in a time format, okay, just a time span. And I prepared a function to do that. So if we go there, we can see the function. Someone may say, okay, but it's not really performant. Well, it is, but yes, it's not a really, well, it's not a great deal, but I really ensure that the performance are pretty good. Okay, so in this case, we are just replacing some text and try to cast the result into a date time. Okay, so that's, say, try to apply the function to this field, and we have the time span. That is nice because we can use it in a computation. Okay, the rating also, we can say try cast this as a decimal. So the rating can be from 0 to 10. So 2 digits before the comma and just 1 after that. So we can cast it as a decimal of max 3. 1 for the after comma. Okay. Okay, and we're ready. So if we just comment this and take the top 10, we have a good result. And also the plot synopsis is okay. Okay, good. But the real power of that is not just this. It's when we deal with arrays. Okay, so this is the movie part of the row, and I will comment it a second. But there's the reviews part of the row. In the field, I didn't remember, reviews. So this is an array. The type is this one. Just a second. In the meantime, I look for the questions in the tool. Questions. Okay. Good. This is the type. Okay. So, but before doing this part, we need to take it one by one and make the like a join between each item on the review array with this row as the join. Okay, as the join between the two relational database. So, just to be clear, we can go straight to a single item dot review date. Okay, and it's okay, but this is the first item. Okay, so it's not, it doesn't make sense really. Okay, but we can do this. We can say, hey, take the movie JSON and apply all the rows to the unarrayization. Okay, I know it's not an English word. Okay, but I just invented this of the reviews field. Okay, let's give a try of this. It takes a long time. Why? Because for each array item that it discovered inside the reviews field, it produces a row merging the other fields. In this case, just this one. Okay. But which is the approach here? Stop it. Okay. The approach is this is not necessary anymore because I really project it here. This is not necessary. Those are the new fields produced. One is the index. One is the type, that it's like the inferred type inside the structure, and one is the leaf that we need to inspect it and produce the fields. Okay, so actually I don't need the star, I just need the value. Okay, and when I have the value, I can do the same. So value of value item review date as review date. And then and now the same as before. Monkey business too. So we have movie ID that I don't want it. User ID is spoiler, review text, rating, review summary. Okay. And you have big JSONs with hundreds of fields, so you can script this part, of course. Rating should be something different, like review rating, because rating is already here. Okay, and we are pretty ready. We perform the same conversion stuff here. State is ready. It's okay. This spoiler can be a Boolean. That is a bit in the SQL conventions. That's a bit. Review text is okay. This is decimal. Okay, and review summary is okay. Good. So let's decomment this part. Good. What's one with you. Political name, no, comma. Okay. And then, so for the single movie ID, we have all the rows in a form that is very similar to DBO VU1. Yeah, movie ID. Okay. Yeah, the plot synopsis is not correct, but I think, oh, okay, I made some mistakes. I don't know, actually. Probably this is an ingestion error, while because this goes into the relational table and this goes into the NoSQL one. So probably I missed some fields during the importing phase. But you saw that plot synopsis is filled in other movies, so should be okay. Good. So now we can create a view on that without the where clause. So this stuff should be a view itself. Create view around my view and reviews from JSON. Nice. And we have this. In this case, this is the execution plan. So we have JSON reading, and we have like a merge, like a join. Okay. And this is the way that the way we can produce results that are compatible with our other tools that needs a relational view into the database. So if you attach Power BI, Tableau, something like that, on this view, it's like a relational view with these fields that are inferred from the casting. But under the hood, there are no fields. There are no relational tables, just JSONs that are transformed in real time, and it is really performant. Okay, so what we saw some functions. So the JSON value that from a JSON, a single document, takes out the property. The JSON query that takes out the content of a property regardless the type. So this is very useful to take sub items that are JSON itself. Open JSON that open a JSON array and transform it to a list of items that you can then apply to a row, join to a row. Each JSON is a function, a binary function, a Boolean function that returns true or false. You should say is JSON body, and it can be used. We didn't use that, but you can use the into constraint checking. So when you create a table and you want to ensure that the content of an varchar max is a JSON, you can add a constraint telling the constraint is JSON of that field is true. Okay. Why this approach? Because we don't have yet the JSON field inside the Azure SQL database. Probably in the future, I don't know. So in the meantime, if you want to enforce the data type, should go that way. Okay, good. So now let's have some fun at the end with some experimentation around data. Okay, I have this table that is called playground. Key value, okay, and it's just ID and doc. Okay, I don't select start because it's like a suicide. Okay, from playground key value, have two items. Okay, and I am telling you that the item 3 is the entire movie's JSON, 14 megabytes, something like that. While the item 4 is the entire reviews JSON, about a gigabyte. Okay? Well, it's why I'm not saying start here. Okay, which is the nightmare that I have in mind? It's a nightmare. It's not something that I want to do in production. It's just to show you how to push this technology as much as you can. I can create a view that takes the specific item 4 and the specific item 3. Well, I switched the two. The 4 is the... No, it's okay. The 4 is the reviews and the 3 is the movie. I took those two documents and I apply the content, if they are both arrays, okay, to then join them on the movie ID field. Okay, so what I'm saying that even starting from a very simple key value store into SQL Server, we can produce the same exact result of the other tables. I don't play with this because it's a nightmare for a reason. So the plan is absurd. I just give you an idea of that. Yeah, from maybe. Okay, so it's very expensive to do this, okay, because he has to keep all the objects in memory to then split the object, read them, split them in split the arrays, merge them with matching, so join them, and this is performed in memory. So this is obviously something to think about it. So you can use a key value store, but of course, keep in mind to not stress too much. It's a relational database yet. Okay. Another thing that I want to show you is the possibility to make history tables on that tables. Okay, so when you deal with JSON, it's very powerful because I put the JSON into a field and I transform it at runtime with the SQL. But after, depends on the context, a month, a day, a year, a quarter, 10 years, okay, it's really necessary to have that fresh JSON data inside the database, and each time I select it through a view, transform it in real time, or we can also transform it permanently, okay? Of course, the second is the better approach. So if the JSON become huge, you have into the database something really big that is probably not necessary anymore. So my suggestion is to denormalize it and store it into the proper place that can boost the data size, so can reduce the data size and the performance of the queries. So let's take some items from here. This is our views. And we can say, take all this stuff, even 10,000 should be okay in this 2 minutes left, into playground.myHip. I'm creating at runtime on the fly this table playground my heap with the first 10,000 rows of this view that is taken from the JSON. Okay, so this is something that you can do once or in a particular specific moment of time, and this is the same. This has the same structure with no foreign keys, with no clustered index. That's why it's called a heap in the SQL world, okay? But I also create something that is more optimized. So the structure is the same, but on that I would create a clustered column story index on this table. What's that? Well, we have now this table. that seems similar, but it has an index that tells the database engine to store the table in a column store format. So not in a row store, in a column store. This is a very common approach in analytical workloads to have faster aggregation logic and so on. And also we can insert some data into background ICCI table. Okay. The same 10,000 rows. I want to show you from the, it's ready, I hope in a few seconds. Yeah, okay. I want to show you that, okay, well, 0 is not really 0, but it's really near to 0. We can see this one and this one. Those are the two tables that I created in the dry run. One is the heap, 3 gigabytes, and one with the same rows is the optimized one with the clustered column store. It's like half a gigabyte. Okay. What I want to say is that you can use that type of indexing to compress the data and also to take advantage of the underlying technology. So if we take this one, that is the full version of the table that I just created with all the 500,000 rows, I can have something like the average of rating in a second, or something here, release date, average rating, grouped by this in a second. Okay, why? Because in this structure we have an index that is a column store index. So keep in mind that column store indexes both compress the data and also store the data in a column store format to be more efficient in analytical workloads like average aggregation and so on. So to recap, Relational is good, and it can be also used for JSON workloads. JSON has productivity in the terms that you have already JSON in place and you want to minimize the effort of engineering tables, adding some fields in case the data changes. In this case, if some fields are added into the JSON, I can just edit the view. I can just recreate the view with a new field mapped to the specific field, and it's okay. And what I wanted to show you in the last few minutes is the sensibility to create some dedicated structures in case you want to make some history tables. So when you don't need anymore to have fresh JSON to the database and just need the data in other format, you can store them in a different way, denormalizing it and storing it in the proper structures. That's all. So if you have any question, I don't see question. I used all my minutes because I didn't see any question in the Q&A, but if you have that, please ask, and if we go out of time, I'm ready, I'm available to answer them offline or through the platform. I'm still here, just shutting down my webcam and mic, and thank you for being here and to follow my session. Bye.